So, welcome everyone to Guided Study Group Week 6 of Math 141 this semester. So, I guess everyone has like a wonderful midterm week, and I hope that everyone did fine on it. Now we're on the materials of midterm 2. So, starting from now, the material is gonna be the majority of what you're gonna expect on midterm 2. So, make sure you take a note of that. And so today we're going to go over section 6.8 and 7.8, which is indeterminate forms of limit, and then we have like proper improper integrals. And I should remember the name of that, but yeah, it's improper integrals. And so first 6.8, indeterminate forms of limit is that when you're given a limit, but the expression inside a limit has one of these 7 forms, then it's considered indeterminate form, and then you have to use the following strategies. So we have 7 forms, which is 0 over 0, infinity over infinity, infinity minus infinity, 0 multiply infinity, 1 to the infinity, 0 to the 0, and infinity to the 0. Now, make sure of the fact that if you have infinity, so they're not infinity multiply infinity, or 0 multiply 0. So make sure that you remember the correct form and don't think like, okay, whenever you have infinity and 0, then that'll be indeterminate form. That's not right. And so ways that you're gonna do it is that when you're given, say, the first 2 form is a quotient, what you're gonna use is something called the Hospital rule. So what to use this, you have to make sure, say you have f over g, then you make sure that both of them are differentiable, because based on this L'Hopital method, what you're gonna do is that you're gonna take derivative of both the numerator and denominator. So make sure that both of them have to be differentiable. Then you have to do this thing, you also make sure that it's in the 2 quotient form of the 7 indeterminate forms of limit. Then the denominator, so limit of x approaching a of gx is not 0 as well, because if it is, it kind of like violate the so it's kind of like violate the conditions that we can apply this part, but usually this is not a problem. So then you have this limit. So to solve the limit given, what we're going to do is that we're going to take derivative of both the numerator and denominator. So instead of fx over gx inside the limit, now you're going to have f prime x over g prime x. And this method is going to continue until you have until 0 over 0 or infinity over infinity disappear. So like you apply that every single step, and you have to make sure that you check every single step as well until the time that it disappears. Then you stop. You don't use the L'Hopital rule anymore, because it can even change your answer as well. Product. If you're given a product like 0 multiply infinity, so the way that you're going to do it is just very easy. Make it into a quotient. So it's just like an algebraic formula where you have fx multiply gx is equal to gx over 1 over fx. So just a different way to write the same thing. So that's, and then after that you go back to the quotient method. If you're given a difference, say you can also make it into a quotient using either common denominator, so like a quotient minus a quotient. Then you can make them into the same denominator here, and then whatever is going to happen in the numerator when you make them into the same denominator. Or you can multiply the conjugation. Say you have square root of something minus something. You can multiply both of them by square root of that plus that, or square root and over square root of that plus that. So it essentially you just multiply by 1, but instead of 1 you write in the formula. Will be helping you in the problem. And then you have ln of something minus ln of something. This is using the property of ln. So ln of difference of two ln is going to be ln of the quotient of, say this is a and this is b, is going to be a over b. This is kind of like one of the property of log function. Finally, if you are given a power, say 1 to the infinity, 0 to the 0, or infinity to the 0, then you have to make it into a product, then a quotient. So say if you have fx to the gx, you can put it into, it's going to equal to e to the gx multiply ln of fx. Because you know the fact that if you have a is equal to e to the ln of a. So by putting this into a product, now when you take the limit, so you don't need to care about the e, because after you find the limit of, say, x approaching b of gx, ln of fx, after you find this one, by making it into a quotient, say here you have ln of fx over 1 over gx. After you found this, you can plug it back in and you can find e to the whatever it is. And so the very important step here is that after you find this limit, make sure you plug it back in to get the final answer. Stopping there doesn't give you the final answer, and most of my students at their few efforts trying to like solve the problem, they usually forget that and they email me like, okay, why did I get this thing wrong? So most often you get everything right until the end and you forget the exponential. So now let's go to example 1. So example 1, the first step in every single of these problem is make sure that you identify the right form and then you figure out what to do with it. And so here when you plug in x approaching 0 plus in, you have, what you're gonna have is 0 to the, okay, ln of x cubed. So x cubed is going to be also 0 plus, approaching 0 plus. ln of 0 plus is negative infinity, and 1 over negative infinity is another 0. So what I'm going to do is that I'm going to rewrite this in the form that I need it to be, x approaching 0 plus. So first make it into a product. So it's e to the 1 over ln of x cubed, ln of x over 2. And so now I just take the e out and then find the thing inside and I need it. And so it's ln of x over 2 over ln of x cubed. Now let's just find ln of x approaching 0 plus. Limit of x approaching 0 plus ln x over 2 divided by ln of x cubed. Now put into that thing, now you have infinity over infinity. So you have a quotient already. So now we're going to use L'Hopital rule, limit of x approaching 0 plus. L'Hopital rule, derivative of the numerator is 1/2 over x over 2, so it's going to be 1 over x, divided by the denominator is going to be 3x squared over x cubed. So now we have limit of x approaching 0 plus. Note that from here to here, it's just algebra. I don't do any L'Hopital at all. So we have x squared over 3x squared again from here. So that's why I wrote this h here, because I think it's a very good step for you guys to keep track of what you're doing, and when you come back and like track your step and see why you don't get the answer from what was given, the choices are given. So that'll be a very helpful way, because you know what you did there and you just need to check through like, okay, did I make any mistake in this step? But the method is generally right. And so here it's going to be x approaching 0 plus of 1/3, which is going to be 1/3. Note that x approaching 0 plus. So x squared is still different from 0. So you can cancel out that in the numerator and denominator. So what you have left is 1/3. So now last step, very important step, put it back, so e to the 1/3. So that is my final answer for this question. Again, make sure, so whenever I go through every single step, if you don't see the form of 0/0 anymore, don't use the Hospital rule. And make sure that you put it in the correct form and use the correct strategy that I put in the previous slide for that. Now we go into the example 2. Example 2, when you plug in x approaching infinity, what you have here is that first is you're going to have infinity minus infinity. And so the first step is to make it into a quotient. And as I said here, the first thing I'm going to do is multiply their conjugation. So you multiply x approaching infinity of square root of x squared minus 10 minus x plus 2. So multiply the conjugate is going to be square root of x squared minus 10 plus x plus 2. And then square root of x squared minus 10 plus x plus 2. So essentially you multiply by 1, but it's a different way of writing 1. So now you have limit x approaching infinity. So the numerator is going to give you, based on this, you have a minus b, multiply a plus b is equal to a squared plus b squared. So a here is square root of x squared minus 10. So your square is going to be x squared minus 10 multiply minus x plus 2 square. And in the denominator, you have x squared, square root of x squared minus 10 plus x plus 2. So now, let's do the algebra. So you have, it's going to be negative 4x, negative 14 over square root of x squared minus 10 plus x plus 2. So now what you end up having here is that you're going to have negative infinity over infinity. It's one of the indeterminate form as well. So there are two ways you can do it. Here you can use the Hospital rule as you learn, or you can just take x out of the numerator and denominator. I'm going to try the Hospital rule first, and then I'm going to do the normal step I can do. Because this is like an extra way that you can do it in case that you will get stuck in the future. So limit of x approaching infinity. So now if I take the Hospital, so take derivative of both the numerator and denominator. So you're going to have negative 4 over this one is, you're going to have x over, actually 2x over square root of x squared minus 10. There's no 2 there. So x. Because it's to the power of half. So when you take derivative, is going to be take the half outside. So 2 cancel out with 2 plus 1. And obviously you can see the fact that as limit of x approaching infinity of this term is going to be 1. So our final answer is going to be negative 2. Because negative 4 over 2 is negative 2. Another way to do it is that you can take x out. So it's essentially the same thing. So you have x out, you have negative 4 minus 14 over x. Here, because x approaching infinity, so when you take x out of the square root, it's going to be 1 minus 10 over x squared plus 1 plus 2 over x. Note the fact that because x approaching infinity, square root of x squared plus something is going to be x over 1 plus that thing over x squared. But if x approaching negative infinity, this thing is going to equal negative x square root of 1 plus that thing over x squared. Remember, this negative if x approaching negative infinity. And so, by doing this thing, we kind of have the same thing when we can cancel out this x. So what we have left is limit of x approaching infinity, negative 4 minus 14 over x, divided by square root of 1 minus 10 over x squared plus 1 plus 2 over x. And now, because x approaching infinity, this thing is approaching 0, this thing approaching 0, and this thing also approaching 0. So what you have left again is negative 2. So -2 is my final answer for this question. So again, there are two ways you can approach it as you go to like infinity, as you make it into a quotient already. If you have this kind of form. So having said that, we'll go to example 3. So example 3, find the limit of theta approaching pi over 2 of 1 minus sine theta over cosecant theta. Now when you put in pi over 2, what do you have? You're gonna have 0 over 1. And this is not indeterminate form. Because cosecant is 1 over sine, and sine of pi over 2 is 1, so not indeterminate form, meaning you just say it's equals 0 because the 0 over 1 is 0. So this is important because I put an example here to show you the fact that, okay, even though you learn indeterminate form of limit, you don't necessarily apply it everywhere. Make sure that you check the form for every single questions and through every step that you take L'Hopital, because if not, most of the time your problem is that you're going to take way too many L'Hopital or you apply the wrong strategy because it's not the indeterminate form. So having said that, I think it's good enough for this section. Let's move on to 7.8, improper integrals. So when we say improper integrals, there's some problem with our boundaries of integrals. So first you have infinite, type 1 is infinite integral. It is infinite integral when you have at least one of the boundaries related to infinity or negative infinity, and we have two forms here. First one is you have upper boundary is infinity. Second one, you have lower boundary is negative infinity, and the last one is you have both boundaries be negative infinity and infinity. And these are gonna be the way that you're gonna do it. So first step of you is gonna rewrite the integral into, say, the first thing is, if you have integral from a to infinity, you're gonna rewrite as limit of t approaching infinity from a to t, and of the integral from a to t. And similar thing for the second type. And if you have like both of them, you're gonna rewrite in two steps. So kind of like the first thing is that you split it into from 0 to infinity to negative infinity to 0, and then you apply that. Now if the limit exists, say if if the limit we have here 1, 2, 3, 4 is not exist, so the result is not dne or plus or minus infinity, then your integral converges. However, if you look at these, if this one does not exist or plus or minus infinity, then for sure it's divergent. However, for the last one, if you have one of them is divergent, so say one of the two be dne or plus or minus infinity, then the entire integral is already divergent. One of the commonly seen expression is that when you have the integral from 1 to infinity of dx over x to the p, then this thing is going to diverges for p smaller than or equal to 1 and converges for p bigger than 1. Remember, there's no equal here. If you Google it online, you can see like the specific proof for these questions, but so I wouldn't be like mention it now because that's not our focus to prove this. Just putting it here so that you guys can easier keep track of like kind of like get through this problem faster. We also have type 2 called discontinuity integrand. So in one of the boundaries, we either have the discontinuous at the upper level or discontinuous at the lower level, or we have discontinuous as a number inside a level. So what you can do for the last type is, for the last one, is that you can kind of like, so if you have from A to B, you kind of like have an instinct that you're going to put it into from A to C or C to B. However, to make sure that this equal sign is put over here, have to make sure that both of them are convergent. So if you find that one, like say one of the component integral, and say find integral from a to c, and you find it's divergent, the first step is, so you can immediately conclude that this thing is divergent, like the big one is divergent, and this equal sign does not happen. Or you can conclude that you cannot find the integral, something like that. And then you also have something called the comparison theorem. So comparison theorem is, say, if you have both functions are continuous and the function g is squeezed between 0 and f for x is bigger than or equal to a, then you have the integrand from a to infinity of fx. If that one is convergent, then gx, which is smaller than fx, also convergent. Similarly, if you have gx is divergent, integral from a to infinity of gx is divergent, then the bigger function, integral from a to infinity of fx, is also divergent. So it's kind of like making sense. So if like the big function is convergent, smaller one have to also be convergent. But if you have the smaller one already divergent, the big one, of course, is going to be divergent. Now, having said that, let's jump into the example to make it clearer. So the first one is integral from negative infinity to infinity of 2 to the x dx. So let's see what I'm going to do here. So first thing, this one is equal to 0 infinity to infinity 2 to the x dx plus negative infinity to the 0 2 to the x dx. And so now you're going to find each of them to make sure that you get both of them convergent to get this equal sign to happen and find the final answer for this. So when I find from 0 to infinity of 2 to the x dx, this one is limit equal to limit of t approaching infinity from 0 to t 2 to the x dx. And so the integral inside is easy now. It's just 2 to the x over ln of 2. From 0 to t. And so this one now is going to equal limit of t approaching infinity 2 to the t over ln of 2 minus 2 to the 0 over ln of 2, which is 1 over ln of 2. Now, limit of t approaching infinity of 2 to the t, this part only, is infinity. So our answer for this is infinity. And so, because only one of this, so because 0 to integral from 0 to infinity up 2 to the x dx is divergent, you conclude that from negative infinity to infinity up 2 to the x dx is divergent. And so our answer here is that you cannot have a value for this integral because it's divergent. Now, let's go to example 5. Example 5 is integral from 0 to 1 of x squared ln of x dx. And so when you look at this thing, first thing is that you don't really see the discontinuous, but when you look closely at it, ln of x has a discontinuity at 0. The graph of ln of x as x approaching 0 is this. ln of x is going to approach negative infinity. And so our problem here is that you have ln of limit of t approaching 0 plus from t to 1 of x squared ln of x dx. Now, our part is to use integration by part to find what is the integral inside. So I have a small step here. Find what is x squared ln of x dx, integral of that. So let's put u equal ln of x. du is dx, and this is purely exam 1. So you should be able to do this thing. dx is x squared. dv is x squared dx. So you have v is x cubed over 3. So you have this is going to equal x cubed over 3 ln of x minus x cubed over 3 dx. And so this one is going to equal du is equal 1 over x actually, so it's x squared. So we have x cubed over 3 ln of x minus x cubed over 9 plus c. So now we're going to put it back to here. So let's have limit of t approaching 0 plus of x cubed over 3 ln of x minus x cubed over 9 from t to 1. So when you put 1 in, what you have is that you have 0 here minus 1 over 9 plus, actually negative, limit of t approaching 0 plus t cubed over 3 ln of t minus 0. Because t cubed over 9 with t approaching 0 is 0. So it's end up being negative 1 over 9 minus limit of t approaching 0 plus t cubed over 3 ln of t. Now, having said that, looking at this part only now. When you have t approaching 0 plus, what you have is that you have 0 multiply infinity. So this is multiply negative infinity. So this is an indeterminate form. So the second small step here is that you have to find limit of t approaching 0 plus of t cubed ln of t. And so limit t approaching 0 plus. And here you have a product. So this is now using the material from the previous section 6.8 we just learned. And so this is a product. So the first step is that we had to put it into a quotient. Sorry for that. Continuously changing style. ln of t over 1 over t cubed. Or you can rewrite it as ln of t over t to a negative 3. So now what you have is infinity over infinity, because t is approaching 0 plus. So 1 over 0 plus is infinity over infinity. So I'll put the form here, keep track. So now it's going to be the L'Hopital rule because you have a quotient. Limit of t approaching 0 plus. The derivative of the numerator is 1 over t. And of the denominator is negative 3 over t. Actually, it can be negative 3 t to the negative 4. And so what you end up having is that you have limit of t approaching 0 plus. So this step is just purely algebra. And so it's going to be t cubed over negative 3. And as t approaching 0, so this thing is just going to be equal 0. So what you end up having for the entire thing is that you have from 0 to 1 of x squared ln of x dx is equal negative 1 over 9. Let me check my final answer if this thing is correct. So I have that one is F. So yeah, this thing is correct. And so looking back at our process, so there are many things that you have to do here. First is that you use the knowledge from exam 1 to find what is that integral, and that's using integration by part. Second one is that you identify that there is an indeterminate form of limit exists in our final answer. You have a feeling what is that number is. So you have to find that using the materials from like 6.8. And then we get our final answer. And so this is not a very hard one, but kind of challenging one because it used multiple materials from many sections. And so this is the kind of exercise that you should expect in the exam. So it's not too hard, but it's gonna have a cumulative technique that you learn, like cumulative in knowledge that you learn from exam 1 and then what you've learned so far in exam 2. So having said that, let's go to our last example today. This is finding the integral from 0 to 5 of w over w minus 2. And the first thing that you can see here is that we have a discontinuity at 2 because is in the denominator. So what you do is that you have w over w minus 2 dw plus from 2 to 5 w over w minus 2 dw. Then you can rewrite it as limit of, so now find each of them individually. So you find the one from 0 to 2 w over w minus 2 dw is going to be limit of t approaching 2 minus 0 to t w over w minus 2 dw. Here, now you have to find what is the integral of w over w minus 2 of dw. I have a really good way to find it. Let's do this and kind of like, so instead of w, I rewrite it as w minus 2 plus 2 over w minus 2 dw. And so what you have right now is that you have 1, because this divided by this is 1, plus 2 over w minus 2 dw. And now it's way easier to find the integral. So you're going to be w plus 2 ln absolute value of w minus 2 from 0 to t. And so when you put in limit of t approaching 0 minus, so this is not exactly an equal yet. I kind of like forgot the fact that you have to make sure that both of the component integral are convergent before you can put that is an equal sign. So now you find each of them individually, and if you find one of them is divergent, you can immediately conclude that you cannot find this integral because it's divergent. So what you have here is t plus 2 ln of t minus 2. And then when you plug in 0, so you have minus 0 plus 2 ln of 2. So looking at here, when you have t approaching 2 minus, you have 2. But here you have ln of 0. When you take 0 minus and you take absolute value of that, so ln of 0 plus. So now you have minus infinity. And so here, what you end up having is that this is going to be divergent. You can say like minus ln of 2 as well here that you have. But this is divergent. So what you end up having right now is that your conclusion will be in the integral from 0 to 2 of w over w minus 2 dw is divergent. And so integral from 0 to 5 of w over w minus 2 dw cannot be found. Or you can say it's divergent as well. But I mean, and as you go to upper level of class, you might be able to find what is this value essentially. But for now, what you can conclude is that you cannot find that using what we learned so far, say cannot be found using maybe improper integral strategy, or you can say that it's divergence. It's up to you, because up to this point, your knowledge and my knowledge doesn't allow us to find what is this integral. And so that's all I have for today. If you don't have any other questions, these are the practice problems, and I highly recommend trying them, as well as the suggested problems that Dr. Katarzyna put on there, because I think they're really helpful and it helps you prepare for the exam. Some of them I already have a look at them, and it's kind of like similar to the cumulative problem that is in example 5. And so I think it's a very helpful practice because it's really close to what you should expect in the exam. So having said that, I'll end the sessions here. Thank you for coming here, and I'll see you guys next week.